Show that the gradient of the curve 2x squared plus y squared equals 3xy at the point 1, 2 is 2. So we need to differentiate here. So differentiating with respect to x gives us 4x plus 2y dy dx is equal to, now this one's a product, so think about u being equal to 3x and v being equal to y. Then du dx is equal to 3 and dv dx is equal to dy dx. So we get v du dx, so that's 3y, add u dv dx, 3x dy dx. So 2y dy dx minus 3x dy dx is equal to 3y minus 4x, and so dy dx will be equal to 3y minus 4x over 2y minus 3x. So we want dy dx to be evaluated at the point 1, 2. So that's going to be 6 take away 4 all over 4 take away 3, which is 2 over 1, which is 2. Another curve passing through the point -2, 10 has a gradient given by dy dx is 2xy over 1 plus x squared. We want to use a method involving separation of variables and integration to determine the equation of the curve. So we have dy dx is equal to 2xy over 1 plus x squared. So separating, we get 1 over y dy, and we need to integrate that, is equal to the integral of 2x over 1 plus x squared. Now, integrating the left-hand side gives us ln y. On the right-hand side, since the top is the differential of the bottom, we get ln 1 plus x squared. We also have a constant, and in this case I'm going to call that constant ln c, so that we can say ln y is equal to ln c 1 plus x squared, just using a log law, and then y must be equal to c 1 plus x squared. Now let's use this. So we have 10 is equal to c into 1 plus 4. So 10 is 5c, and that means that c is equal to 2. So we have that y is equal to twice 1 plus x squared. A particle is moving along the curve given by y is the cube root of x with 1 unit on both axes equal to 1 centimetre. When x equals 1, the y-coordinate of the position of the particle is increasing at the rate of 2 centimetres per second. Show that the x-coordinate is increasing at 6 centimetres per second at this instant. So we have dy dt is equal to 2 when x equals 1, and we're required to find dx dt. Now y is equal to x to the third, so dy dx will be equal to 1/3 x to the -2/3, which is 1 over 3 times the cube root of x squared. Now dx dt could be written as dx dy multiplied by dy dt. So dx dt when x is 1 is going to be, so dx dy would be 3 times the cube root of 1 squared multiplied by dy dt, which is 2, so that's 3 times 2, which is 6. Determine the exact rate at which the distance of the particle from the origin is changing at this instant. Well, the distance from the origin is going to be the square root of x squared plus y squared, or x squared plus y squared to the half. So if we want dd dt, that's going to be a half x squared plus y squared to the negative a half multiplied by 2x dx dt, so that's this one differentiated with respect to t, plus 2y dy dt. And we're looking at x equals 1, y equals 1, because the cube root of 1 is 1. We have dx dt is equal to 6, and dy dt is equal to 2. So it's going to be equal to a half of 1 plus 1 to the negative a half, then 2 times 1 times 6, add 2 times 1 times 2. So that's a half times 1 over root 2 multiplied by 12 and 4, which is 16. So that's going to be 8 over root 2, which is 8 root 2 over 2, which is 4 root 2 centimeters per second.